Good morning from the Johnson Space Center here in Houston. I'm Dan Hewitt. Two Expedition 39 astronauts are getting ready to go outside and do a spacewalk to replace a failed backup relay computer. Here to give us a status update and walk us through the spacewalk, we have Mr. Mike Suffredini, the International Space Station Program Manager. He'll be joining us from the Kennedy Space Center down in Florida. Here in the room, we have Brian Smith, International Space Station Flight Director, who will be overseeing the EVA as it comes up. We also have Glenda Brown, the lead spacewalk officer for EVA 26. We'll start off with opening remarks from each of them, and then we'll open it up for questions. Why don't we start off with Mike Suffredini down in Florida.
Well, good morning, everyone. This press conference is supposed to be about the EVA, but we'll talk about what's most immediate in our future, and that is the launch of the Dragon spacecraft out at Launch Pad 40. The Falcon rocket itself has been repaired since the discovery of the orifice issue during the last launch countdown. That's all been repaired. We put fresh science on board, buttoned it up, and rolled out last night. The vehicle is currently at the pad, and we're counting down to a launch at 3:25 this afternoon local time. Of course, the big question mark is the weather. I think we're still at about predicted to be 60% chance of no-go as a result of weather. However, a big part of the challenge is just getting out there and being ready in case a hole opens up. And so that's where we're at. That gives us the best chance of success. And in fact, once this little frontal boundary passes over, there's a pretty good chance we'll potentially find a hole in the weather and get off the pad. If we don't make today, then we'll do a scrub turnaround for 24 hours and try tomorrow about 23 minutes earlier. That does affect the EVA plan. If we launch today, the plan is to do the EVA on April 23rd. We'll launch Dragon, we'll berth Dragon on the 20th, about 7 in the morning Eastern time. And then we have some research we need to get started on, so we'll open up the hatch, we'll get the research started, and then we'll get things configured for the EVA. We also have a Progress 53 Progress that has to depart as well, so the crew will get up in the morning, we'll get the Progress on its way, and then we'll conduct the EVA. Brian and Glenda will talk to you in detail about the EVA, but I will talk a little bit about the where we are from a wrist posture standpoint. The EVA, since we had the anomaly a year or so ago with Luca on board, we have been working diligently to understand the cause of the anomaly and to recover from that cause. But in the process, we have done a thorough review of all of our processes and procedures and our hazard reports, and we established a goal for ourselves to have all of that work done before we did a planned EVA. However, the vehicle keeps flying and keeps operating, and occasionally we have contingency EVAs. We've done one of those already, as you know, to do a pump module replacement, and we're prepared to do this one for this EXT MDM that has failed. From a risk standpoint, we better understand the cause of the anomaly. The anomaly is due to contamination that was likely introduced by a filter that was used to clean the system. We have since scrubbed all of the suits, water lines are removed. Basically, we've replaced the water or flushed the water 3 times, and all 3 of the suits on orbit and the cooling lines in the station that provide cooling and water to the suits. In addition to that, we've of course replaced the filters now. We have good filters on board. We have replaced the fan pump SEP that got clogged up in EMU 3011, which we used for a previous EVA, the pump module EVA, and we just did the fan pump SEP R&R for suit 3005. And so the team is going to recommend to the mission management team here next week that we utilize those 2 suits, and they've been prepped and they're ready to go, and I'm sure Brian and Glenda will have more to say about that. One of the challenges with these suits is to understand the water chemistry, and we're learning quite a bit about water chemistry in the suits and the sensitivities and the contaminations that can be scrubbed out and those that are very, very difficult to scrub out. So in this process, we have become quite I would say, more adept at figuring out how to keep the water clean and the significance of certain constituents in the water and their effect on the suit itself. So as part of the process that we're going through to continue to plan DVAs, we're updating all of our hazard reports. And of course, we need to do our final failure analysis and conclusion for the anomaly to make sure that we've repaired all of the, or chased all the possible fault tree branches to a complete closure. But again, the preliminary information seems to point to the filters. Those, of course, have been removed and replaced with good filters, and the water's been flushed, and so we've reduced the risk back down to an acceptable level. So we have great confidence with the EVA that we have planned. It'll be a relatively short EVA. Rick and Swanee will go out and do the EVA, excuse me, and Koichi will help them get ready to go out and manage the EVA from inside the ISS. So with that, that's all my opening remarks. We're ready to go both for the launch today and for the EVA on whichever day it turns out to be required. Thank you very much.
All right, thanks, Mike. Brian?
All right, good morning, everybody. Let me give a brief overview of what we're talking about with the computer failure. We refer to it as the external multiplexer-demultiplexer, or EXT MDM as we refer to it. To put it in context, there's 46 computers on just the US portion of the space station. 24 of those are external. And of those 24, this EXT MDM controls 12 of them. So it's very important. We have 2 of them. We run 1 at a time, and we always have 1 in backup. Last Friday afternoon, during normal operations, we powered on the backup EXT MDM and the intent was to load some files to it. We do this periodically based on the operations that are going on board ISS. We had issues with this MDM powering up. We spent Friday afternoon and Friday evening attempting to get it to power on, boot up correctly, and communicate. We were unsuccessful, at which point we declared the MDM failed. Late Friday night, the ISS program directed the Mission Operations Directorate to initiate a Team 4 effort. Most of you are probably familiar with the terminology Team 4 because we just did this back in December. Team 4 efforts are started when there's a serious problem on space station that needs to be solved in relatively short order to put the ISS in a better risk posture. And so the Team 4 will consist of all engineering operations, all support personnel necessary to solve the problem. And the team makeup will vary depending on what the nature of the problem is. I've been leading this Team 4 effort since early Saturday morning, and the teams have done a fantastic job trying to figure out how to solve this EXT MDM problem. As Mike alluded to, this isn't a long EVA. There's certainly EVAs that are more complicated than this one. However, the real trick has been to figure out how to put this EVA in the same week that we're doing the Dragon mission and we're doing the 53P progress operations. Each one of those individually has its own constraints, its own systems configurations that we need to account for. And we know how to do each one individually. And we usually keep these events spaced apart. In this scenario, though, we need to execute them relatively close to each other, and that was the real challenge for Team 4. We were tasked to go figure out how to replace this EXT MDM as quickly as possible, at the same time trying to fly this Dragon mission in the presence of the next worst-case failure. The next worst-case failure in this situation would be loss of the 1 remaining EXT MDM that we have. So I'll briefly describe what would happen if that were to be lost so you understand the criticality of going and replacing it and why we need to do this spacewalk in short order. So if we were to lose our remaining EXT MDM, we would lose our ability to control our solar array rotary joints, our SARGs. We need to control those, one, for power generation, but also there's a large number of constraints on these solar arrays. We don't want to have thrusters pluming them when vehicles are coming in. We don't want to erode or contaminate them. And so there's a number of constraints that need to be satisfied, and we always put these solar arrays, we always command these sarges into a particular position. We lose that capability. And so the impacts would be to things like Soyuz dockings, undockings, Progress dockings and undockings, Dragon missions, Cygnus missions. And so it's imperative that we maintain the fault tolerance on these EXT MDMs, and right now we don't have that. Some of the other issues we would run into is being able to power on redundant equipment that's on the outside of the space station. A large number of the commands that are required to turn on and off our redundant equipment pass through an EXT MDM, and without that we lose our ability to activate the other equipment. We also lose some insight and command capability into our external control thermal loops. So these are what we talked about back in December when we had the loop alpha problem. The loops will continue to run without an EXT MDM, and we have all the failure detection and isolation and recovery software in place. We just lose our ability to see the telemetry and to change the configuration. So because of these impacts, this particular failure was put on a list of critical failures that we would respond to quickly and we would go do an EVA for. And a lot of the work was done up front for this EVA, and we were able to capitalize on that when we started our Team 4 effort. Throughout the week, the teams have worked extremely hard. We've worked very long hours, and we've come up with plans that would accommodate not only this EVA, but also the Dragon mission, as well as the Progress operations. And we've come up with 2 different plans depending on when the SpaceX launch occurs. Whether it occurs today or tomorrow, we have those plans ready to go.
All right, over to you, Glenda.
Okay, to give you a few more details about the EVA itself. First of all, let's talk about the crew members. Our EV1 is Rick Mastracchio, and this is his 9th EVA. He's already got logged 51 hours and 28 minutes. And then EV2 is Steve Swanson. We call him Swanee. This is his 5th EVA. He's logged 26 hours and 22 minutes on his previous EVAs. Altogether, we've had 178 spacewalks up till now, maintaining and building the International Space Station. This will be our 179th. Brian mentioned a lot of team members working together to pull together all of the plans. The work started several years ago when we identified that this was a critical spare. We formed the failure response action teams, or FRATs, and it's a bunch of engineers that get together, they review all of the documentation, and then they prepare all of the work that would come prior to and development of this EVA, right down to the very last stuff that we need to do that is specific to this particular event on this particular day. So most of the hard work was done for us, and now it's just packaging it all together and putting it together into one EVA. We'll be assisted during the EVA by Ground IV Jeremy Hansen. I'm supported by a number of people gathering all of that information from the host of engineers. In my back room, we'll have Sandra Moore at the task console. We have Sandra Fletcher at the EMU console. Reagan Cheney is our airlock support, and we have Greer Wilt helping all of them out. They'll be gathering all of the inputs from the team that need to be gathered during the EVA. If there's a response that the crew needs, we've got a lot of people standing by to provide that information. So let's go ahead and run the video so we can see just what we're going to be doing during these EVAs. Go ahead. So our EVA to repair the XMDM, or external multiplexer-demultiplexer, will begin as we always do at the Quest airlock. As you can see here in the center of the photo, we egress through the airlock at the nadir hatch. EV1 will exit the airlock first. That'll be Rick coming out first, and Steve will follow him out. Between the two of them, they'll manage the hardware that they're bringing out. We're showing several bags here, but what we really boiled down to now is just the one ORU bag containing the MDM that will translate to the work site. They're going to carry all their other tools on their persons. They'll translate up the CETA spur, up to the handrail, up to the S0 face 1, and work along the CETA handrail. Face 1 is where the mobile transporter that holds the SSRMS is normally parked right over the top of these MDMs. We've moved that out of the way, and it's at worksite 2 now. They'll be getting into position, stowing the bag that's got the ORU in it, stowing any other tools that they bring with them that they want to have handy. And then Rick will get into position in a heads down position in front of the MDM. There's the MDM right there, and we're going to, rather than show him over the top of the box, we'll leave him out of the way for the purposes of this video. When they get to the work site, they're going to look around and see if they can find any damage. If it's daylight, we'll take some photos. If it's darkness, we'll go ahead and proceed to get the work done. Rick will get into position and remove the handling tool, or the scoop. We call that a scoop because it looks like an ice cream scoop. He'll remove that, and then he will drive the 3 bolts that are on the front of the MDM. I've got the MDM here in the room, and I'll show you that when we're completed with the video. Steve will be standing by and helping him out with access to any of the tools that he needs, taking anything away from him and stowing it. Here we have him just handling the scoop to give you an idea of how he would be moving things around. So the scoop gets installed on the front of the box. We've decided to bring it out installed on the front of the ORU bag, and we'll install it here onto the failed unit. We have to drive the bolts first before we install the scoop, and so it'll be ready to pull right on out as soon as we drive those bolts. We'll temp stow it out of the way, and we picked a nice safe spot that we'll most likely use down inside the truss. We'll tie it off to a handrail there so it's out of the way while we do the work with the new box. There'll be an inspection of the cold plate and the bracket that holds the blind mate connectors, which I'll be showing you in more detail afterwards. And then they'll access the new MDM out of the ORU bag. Steve will help out as needed to hand that off to Rick. They'll be inspecting both the new ORU and the cold plate one last time before they slide the 2 together. Again, it's got 3 bolts, so we'll just install the center jacking bolt first and then use the other 2 tie-down bolts to hold it in place. If we should have any trouble with either of the outside bolts that hold it in place, we'll be good to go with just the center jacking bolt. That just provides some extra security to the box. Then we take the scoop off of the new ORU, stow it for return to the airlock, and then pack up all of our tools, pack up the ORU bag, and do some final inspections. If we haven't had daylight when we first come out, we'll take the photos at the end of the work, and then pack up everything and come inside. We have to pack up the ORU. The failed ORU goes back into the ORU bag before we can come back to the airlock with it. So grab the bags and head back inside. We follow the same translation path that we come out to the work site on to return back down to the airlock. So you can see it's a pretty simple EVA in terms of the overall work that we have to do. It's just coming out to the airlock, driving 3 bolts to remove the failed unit, removing it, temp stowing it, and then installing the new one. Very straightforward. At the end of the EVA, they'll come back inside, and we'll be done. So now if we can look at the MDM that I brought with me. So this is what the size of the box looks like. The one difference is this mock-up is for a new box that we're going to be installing next summer on an EVA, and it will not, the box we're working on does not have this electrical connector. That is an upgrade for the new system that'll be installed next year, summer of 2015. So the bolts that I mentioned are right here at the bottom of the ORU. It's got the 2 tie-down bolts here, and then the primary bolt, which is in the middle, that's the jacking bolt. So in order to remove it, you release the 2 outside fasteners first, and then drive the bolt in the primary bolt. And what that does is you drive that bolt out, it screws the box just a little bit, and it'll slowly drive the box out. And then once it's free, they can pull it out of the out of the work site. I'm going to set this here for just a moment to talk to you about what the work site looks a little bit like. This is one of the plastic mock-ups that we have from the neutral buoyancy laboratory, so it's not exactly flight-like, but it does give you an idea of how the installation works. So when you look at the installation bracket, the blind mate connectors will be inside this bracket here. And those will mate with the ones that are on the back side of the MDM. So the MDM has mating connectors, electrical and power and data, in the back of it. The cold plate that it's mounted to is right down here, and then it has these 3 wedge locks that are at the back of it. And the way it works is when you slide the 2 together, you can see there's pins that are on the ORU that go into the slots right here. There's 4 pins that'll just slide into those slots. And then as the 2 come together, the wedges that are on the cold plate interface with the wedges that are on the the bottom side of the ORU. So this is actually a wedge. And then as you put the 2 together, the 4 pins go into the slots, you put the 2 together, and then the wedges come together in the back. As you drive the bolt, when it gets to the wedges drive next to each other to put a nice preload onto the bottom of the box, so it's very firmly mated to the cold plate so that it gets good cooling. With all the electronics in the box, there's quite a bit of heating that builds up there, and we need to make sure that it's got good thermal conductivity with the cold plate on the box. So that is essentially the EVA, and I can answer any of your questions.
All right, we'll go ahead and start with questions. A reminder, we have Mr. Staffordini tied down from Kennedy, so if you could please state your affiliation and who your question is for, it'd be much appreciated. We'll start here at JSC, then we'll go down to Kennedy, and then we'll take questions from our phone bridge. So, Gina?
Yes. How long has that box been up there?
So it came up with the truss that was launched, and I want to say it's around is it 11 years?
April 2002 it launched.
Okay.
STS 110 8A. It was launched in place with the truss.
And you have how many spares?
We have just the 1 spare that's inside, but within the box itself, there are cards, just like in your computer at home. So if there's a failure of any one of the cards, we're intending when we bring that failed unit back inside that we'll replace the card that's failed, and then that will be a good spare for us in the future. Okay.
Okay.
Mark. Thanks, Mark Carreau, for Aviation Week. This might be for Mike Staffordini, but it might be for Brian too. I don't know. What are the plans for the Progress 53? When does it leave and come back?
Okay, so 53P, there's 3 aspects to that operation. There's going to be a prop purge on the 19th. On the 23rd, it's going to undock, and then it's going to come back and redock on the 25th.
And may I ask a question on the MDM? Do you know why it failed yet, or is that a follow-up to retrieving the old box?
So we don't have the exact cause yet. Because the box didn't power on properly and it isn't communicating with us, our insight into it is extremely limited. We have a power signature to work with, but we can't trust the data because we don't think the box is communicating to us. And so that's the extent of what we know right now. We've exhausted our troubleshooting options. We'll see if we're going to troubleshoot it or not. We've got spare cards, and so the quickest posture back to another spare might just be to change out the cards and then test it.
Jim Ogre with NBC, a couple of short ones. On the box, what's the approximate mass of it in terms of handling?
It's approximately 50 pounds. It's just under that.
Okay. Where are they stored inside this ISS?
The spare MDM is stored inside the lab. It's been there for the last 13 years.
Not in the closet, okay. You were going to talk about EVA dates in case of no launch today or tomorrow. Was there some discussion if we didn't launch today or tomorrow that we do the EVA sooner? What dates are you looking at?
So the Team 4 looked at this in great detail. It was very important for us to understand all the constraints of each operation and make sure the ISS was put in the best risk posture in all scenarios. What it boiled down to is if there is a successful launch today, the EVA is on the 23rd. In all other cases, the EVA will be on the 20th.
Sunday?
Correct.
Okay. So today pushes the 23rd, otherwise, no matter what happens, it's on the 20th. Thank you.
Jim, sorry, we're going to move on.
Go ahead. I'll come back to this at this time.
Okay, I think that does it for in here. Actually, we'll come back for follow-ups at the end. Why don't we go down to Kennedy now, and again, please state your affiliation and who your question is for.
Yes, Marcia Dunn, Associated Press, probably for you, Mike, since you're here. I know you have the material on board the Dragon to use for the spacewalk if you can get it there in time. Why not wait for Saturday's spacewalk to get the material? And if you don't get the gasket-like material, what are you using between the box and the cold plate?
So as time has progressed and we've gotten a little closer, the launch is getting a little closer to the EVA in our plan, we've actually decided to go ahead and use the material we have on orbit. Now, the material we have on orbit is the correct thickness. It's not quite cut the same. And so the team has decided we go ahead, and we had determined before we even loaded the material on the Dragon that we could live with the one we had on orbit if we had to. So in the interest of time, today actually we're getting the MDM modified. The crew's put in the, we had to put in a new card in the MDM that's going to go outside in order to get the right boot up software in there, and so we're just about done with that. And then we're going to check it out, the box, using a piece of hardware we have on board. And then we're going to remove the old cold therm and put this modified cold therm. And that's just a timing thing now. When Dragon shows up, we're going to be very occupied with getting the research started, and that takes about a day or so. And then we're going to go right into the EVA preps. And so we wanted to have the MDM all ready to go so we didn't have to do that at the last minute.
Did you pull it off the Dragon, the original repair part, or are you just going to let it fly?
We just let it fly. We'll need it someday.
Okay, thanks.
Okay, next question down at Kennedy.
Yeah, Bill Horowitz, CBS News, with a couple of quick questions. When you said you're replacing a card, Mike, on the spare MDM, and then I assume you're tested this box will have been tested thoroughly before it goes out the door, just because it's been there so long.
Right. That was part of the effort all along, was to check out the box, but we realized that it had a set of boot code software on it that wasn't going to, we were going to be able to work with the new version that we're up to now on ISS, since it's been on board for so long. So the easiest thing to do was take a card we already had and just plug it in. Okay. Almost all these MDMs are interchangeable. The cards are interchangeable inside. Okay, and a quick one for Brian. You were going through the list of things that would happen if if EXT-1 failed. I'm assuming that given all the procedures you put in place for fixed solar array angles and things like that, there are no power downs that would happen if that failed. Is that right? It's just a matter of you'd lose some telemetry and insight into the external thermal control system, but you wouldn't have to, would you have to power anything down if the prime went down? That's it.
That would be assessed on day by day. Of course, that answer is dependent upon the beta angle. So if we have no primary EXT MDM, the solar arrays will eventually stay in auto track. The Sarges specifically would stay in auto track for 24 hours. At the end of that 24 hours, they're going to go to a preset angles. We call those the null angles. We have control over what those angles are, and we've been very strategic about how we set those angles for this upcoming week. But once they get into those null angles, then we just rely on our BGAs, the beta gimbal assemblies, to rotate and generate power. And so we would have to assess day by day as the beta angle changed and our power generation capability changed versus what it was we needed to accomplish on ISS. And it would be quite possible power downs would be required. To the extent, though, it would all depend on what the situation was.
And I would also add, we're low beta right now, which is good for us power-wise. So we're pretty flexible in terms of how we'd manage power if we got into that position. And we're just lucky because of where we are beta-wise.
Okay, next one down to Kennedy.
James Dean, Florida Today. Mr. Safdini, sorry if I missed this, but I was wondering why you wouldn't use this opportunity to stay out a little longer and get a few more things done during the spacewalk, and you're just limiting it to this one task.
Right. Well, that goes back to a number of things. One is we want to get this job done as quick as we can, and so we didn't want to add a whole bunch of other things for the team to go sort out. But also, we've made the commitment that we're not doing planned EVAs and tasks that aren't critical until we get all of our hazards closed and get a final closure on the failure of the suit. So a short EVA actually from a risk posture really reduces your risk. We're very close to the airlock. 2 hours and 30 minutes I think is the time for the EVA. And so that really minimizes the risk to the crew. Now, again, I'll tell you, I feel pretty strongly that we've sorted out the root cause and that our suits are in pretty good shape. But we still have some work to do to finish preparing the suits for long-term use for planned EVAs. And so just to keep everything at the right risk posture, we've chosen just to go do the job we have to do for this critical repair and then get the crew back inside.
Okay, thanks. And just kind of big picture, we're seeing now another contingency EVA after a few months back. And I just wondered if you could kind of characterize, does it just sort of look like there's maybe more things are breaking and there's an increase in the need to go out and do these kind of things, or is this pretty much just in line with expected failures that the failures you'd expect, and things are still lasting as long as you want them to?
Logistically, things are doing very well. We had planned, and if you look at our logistics and our supplies on orbit, our plan is always assumed that we'd have to do something on the order of 6 to 8 EVAs a year. And so we're well below that on average. Although, of course, these two contingencies and the other contingencies every time we have them, we go, we sort through that and we plug that data back into our logistics support analysis we do every year, which essentially updates the mean time between failure for all of our hardware. And then we use that data to determine if we have enough spares on board. But overall, I would tell you the program has been the system's been much more reliable than their initial mean time between failure would have suggested. And from a failure standpoint, we've been, I'd say we're below what we planned for.
Hi, Jared Hayworth. I'm here with the NASA Social, and I'm a photographer with WeHadToday.com. It's a question for you, Mike. One of the most highly publicized payloads on board the Dragon are the legs for Robonaut 2. Can you tell us what steps are remaining to allow Robonaut to be, in place to go out and perform an EVA and do this repair rather than sending out the human astronauts?
That's an excellent question. We have quite a ways to go. The legs are the first step in figuring out mobility, and they allow mobility. There's quite a bit of work to be done from a software standpoint to create a robot that can move freely anywhere you'd want it to on a station and then conduct those tasks. That's an enormous software challenge, and really that's what Robonaut is. It's a great big software test bed. And so these are great first steps, but if you look at something like the Dexter that we use on orbit. Today, Dexter, when we tell Dexter to do something, we have to tell Dexter specifically where to go, and we have to give it basically coordinates and plug it into a system that the coordinate system that the system understands, so it can go to where you need it to go and do the job you need it to do. It's a software-intensive effort. But we have very specific things for it to grab a hold of and very specific interfaces on board station that it can go to. Something like a Robonaut theoretically could walk down handrails, interface with a number of sockets or adapters that you have on orbit, and use a number of tools that you may have on orbit, and that would add to the complexity of the software system to operate outdoors. But the team is off developing the mods necessary to make a Robonaut externally compatible, let's call it. I think the battery pack might have to get a little bit smaller, I don't know, but with the battery pack and the legs and the mods for external, then from a hardware perspective, you'd be ready to go. But like I said, I think the long pole antenna is software. But that's the main reason why it's up there, is to see can you get a robot ready to go to save the risk that you basically assume when crews go outside. They won't ever replace the crews, but they could do a lot of the jobs. I think that you would from just an ORU change out standpoint, that's something you could probably get a robot to do for you.
Ian Kluft with the NASA Social Group and also airlinereporter.com. And so question about today's launch for the SpaceX CRS-3. Looks like quite a significant front coming in on the weather radar. So I wondered, do you know points in the countdown preparations that are sensitive to weather, and particularly lightning in the area?
You'd have to ask the SpaceX guys that specifically. I sat with them last night, and I, from a strike standpoint, they're protected with their catenary system that's around it, and it has to do with the amount of energy that it will find its way back into the vehicle if a strike occurs. And so, if you look at a 30% chance of lightning, the actual chance that they'd have an impact, an energy impulse into the vehicle big enough to cause a retest based on their calculations last night was something on the order of 1%. So it's a pretty low likelihood that if there was lightning in 5 miles predicted at 30%, that you'd actually have a vehicle problem, or at least something you'd have to go test for. But if they have a constraint, or when they stand down launch operations, I don't know specifically if that exists and what that number is.
Marcia at NAP, again from you, Mike. Is the Dragon bringing down is it still planning to bring down the Parmitano suit? I can't remember if any of that bad space suit is coming back. I know it's working. So
the EVA, and it's not coming home. 3015 comes home. It had a sublimator failure early. I don't remember now. I think it's a couple years ago now. We've been waiting to get it down. But that's the suit we're bringing home. 3011, we changed out the fan pump ZEP and all of its filters, and it's one of the suits we're sending outside.
So there's no parts from that incident last summer that you're waiting on for the investigation?
No, we've gotten those parts are home.
They're home, and
we've taken apart. We've looked at them. We've also brought other suit parts home and looked at them. So we have a pretty good insight into what it causes the suit to do.
And how much longer do you think it's going to take for this investigation? And when is that series of spacewalks planned later this year that you had mentioned earlier, for late summer, perhaps?
Yeah, we have it penciled in for July. So that's we're trying to get all of our hazard work done and close the final legs of the fault tree by July. If there's anything hanging out that's critical from a safety perspective, then we'll push the EVAs.
James Dean again, and I was just wondering, it seems like Steve Swanson just practically got there, and I was just curious if there was any limits on how quickly a crew member could be approved to do EVA. Are there ever any concerns about just the adjustment to microgravity and how ready they'd be able to do that, or I don't know, it's probably been a month or something by now. I mean, was that never an issue for this EVA?
It's days that we try to make sure the crews have a little time to acclimate on orbit before we try not to give them a full workload for a few days in order for them to acclimate and get going. And generally speaking, they get going a lot faster. I mean, they acclimate a lot quicker than we necessarily planned for. I don't remember if we have a specific constraint to go outside, but if we leave it to the crews, they go outside when they arrive. So EVA is a pretty big deal, so the crews are always ready to go if we ask them to do it. I don't know if we have a specific constraint, but we can go look at that for you.
Yeah, Mike, and just as long as you're here, I'll ask you a Russian question. How are things going with the Russians, given everything that's going on in the world? Have you guys seen any impacts at all, and how you're dealing with them for ISS or anything else?
Not at all, and that, I believe, is the strength of a partnership and endeavor like this that involves human spaceflight. It's the stability when everything else is getting a little crazy. But our work with our Russian colleagues and their work with us has never been better, and it's clear to me that that's bi-direction of both governments. So we're, it's understood to be very important, and it hasn't affected us at all in terms of how we work together.
All right, that'll do it for questions from Kennedy. We'll go ahead and go to our phone bridge real quick. We'll start off with Charles in News 92. Okay, I think we lost Charles. Why don't we go to Denise Chow from space.com.
Hi, thanks for taking my question. I think this is for Mike, and I think Marcia may have touched on it, and I apologize if I missed it, but do you have a tentative timeline of when you might get back onto your regularly scheduled EVAs, and after EVA 26, what's sort of the main priority?
Yeah, I told Marcia it's penciled in for the July timeframe. And however, if we're not done with all of our work, then we'll move it to the right to make sure we have all of our work done before we do planned EVAs. And I feel pretty confident we'll get all of our work done, but it's a pretty tight schedule. In terms of work after EVA 26, you mean the work we need to do to be able to go outside?
Just what's sort of the main priority outside that you would need to address after EVA 26?
Oh, I see. Well, we have a number of things we have to go do. We have some cameras we need to rearrange to get good views for the SSRMS. We have reconfiguration work. This is probably the biggest thing that's coming up. We have reconfiguration work to do because eventually we're going to move the PMM, which is the pressurized multi-purpose module, the big storage module that's on the nadir port of node 1. We're going to move to the forward port of node 3. And then make that the nadir port of node 1 a backup berthing port. And then we're putting the two docking ports on ISS, one node 2 forward and node 2 zenith. So there's quite a bit of work we have to do to get the ISS configured to first move the PMM, which we need to do before we bring up the we call them the IDAs. These are the docking adapters. We call them the ISS docking adapters. So before we can bring the docking systems on board, we got to move the PMM. Our commitment is to have the docking system on board and installed in 2015. So if you back up and look at all the things we have to do to get the ISS configured to do that, we've got to get on with these EVAs. There's a number of other repairs and things we want to do when we're outside, but the biggest line of things we need to get done is all the reconfiguration work we need to do to get the ISS ready for docking.
Okay, next we have Elizabeth with Universe Today.
Can you give us a sense of what sort of, this is for Mike, can you give us a sense of what sort of changes had to take place in order to make sure that you could do the EVA in between the Progress and the Dragon?
What kind of changes need to take place?
Saying that one of the challenges of planning the spacewalk was trying to getting the task together in between all the other tasks that the crew had to do to get ready for the Dragon, also for the Progress.
Okay, I got you. Well, you know, Brian could give you this in song and verse. He was the one that was given this task to go do. I would tell you though that it's an enormous amount of work for a team to do, and you add on top of that, I mean, it's already hard enough when you've got a Dragon that's trying to launch and you got a Progress that has the Russians have plans to leave and come back. Then you decide you have to do a contingency EVA, and your suit is not already necessarily ready to go do the EVA. So now you've got a lot of work to do to not only get the suits ready, but to do the extra work to make sure the suit system is okay, plus find a hole, plus plan for a launch and a backup launch and a backup launch. So yes, we've kept Brian off the streets with this exercise, him and his team. But maybe Brian would want to add specifically the kinds of things he's had to do to deal with this.
Some of the key things we had to look at first was the crew time. There's a certain amount of crew time associated with the Dragon operations, preparing for the capture, the actual capture, the berthing, and then of course the critical science, which you would get to the next day. You have to ingress the vehicle and get that science started, and some of that science will also be conducted the following day. The EVA timelines also have a lot of preparation work for them. In addition to getting the suits ready and buying down that risk, we had to get the MDM ready. And as we speak, the crew on orbit is preparing that spare MDM. And because we had to change out the processor card and we have to deal with the cotherm on it, it wasn't a straightforward preparation, and it took the teams a while to put that together and then find a hole in the timeline for that to occur. As far as the Dragon Ops and the EVA progress, one of the biggest challenges was finding solar array positions that would accommodate all those. I mentioned earlier, each one of those has its unique set of constraints that will drive our SARGs to be in a certain position. Now we have to find spots with the SARGs that can accommodate all of them, and in the presence of the failure, if we lose the EXT MDM, we want to control where those SARGs go. One set of angles is good for one event, another set of angles is good for another event. We had to find some type of common plan that minimized the risk associated with losing that primary EXT MDM relative to the SARGs, the constraints associated with those, and the power generation. We also, looking from relative trajectories, the spacing of the Dragon Ops and the Progress Ops was something that needed to be looked at very, very closely. We look at the nominal trajectories. We also look at off-nominal abort trajectories, make sure we can keep everything safe, not only from the ISS, but for vehicle to vehicle as they come and go. So at a high level, those were some of the challenges associated with trying to put all these operations within the same week.
All right, thanks, Brian. Let's go to Stephen Clark with Spaceflight Now.
Hi, thanks. Stephen Clark with Spaceflight Now. Just a couple of questions for Mike. First, can you go into a little bit of discussion on when's your drop-dead last launch attempt for SpaceX before moving on to the Orb 2 mission in the case this launch gets tied up with some weather delays? And also, if there's a scrub today, not to be pessimistic, but do you have to go in and service any research payloads before tomorrow? Thanks.
Okay, well, the answer to your first question is we haven't decided yet. We have today's attempt, tomorrow's attempt, and the 22nd as options. I believe we have the 25th as a possible opportunity. And then after that, we got to sit down and talk to folks and decide what to do next. Of course, in SpaceX's case, it's not just when you can launch, it's when you can land, and there's a finite period the vehicle can be on orbit. And we have landing constraints that try to protect, it protects the spacecraft, protects the FAA windows for the aircraft flying in the area, and also we have a certain amount of constraints for payloads back to the dock time. So all those play a factor. So when we're trying to decide when to launch, we're trying to make sure that we have adequate windows for landing. So after the 25th, we'll probably sit down and have a long conversation if the Dragon isn't off the ground at that point. Your question about the backup, if we go on the 19th, we will not resupply any of our research. The Dragon will stay buttoned up. That does have a effect on a couple of our research items, but in the grand scheme of things, it's the right risk trade to make, since we really need to get the rest of the logistics on board ISS. And in both cases, I'll say it's an impact, a potential impact, not necessarily a given that it's going to be unusable research as a result of the delay. So this is why we choose to go ahead and take the backup date.
Okay, moving on, we got Irene from Reuters.
Hi, thanks very much. I have two quick ones for Mike. The first is on the EVAs, are snorkels and helmet pads still required?
Yes.
Thanks. And the other one is on the failure analysis on the MDM that's returned. Will that all be done on orbit, or are you planning to return any of the pieces on Dragon if you can?
I don't know about returning on Dragon, but as Glenda said, my preference is to change the failed component and keep the MDM up there, and then we'll bring the component home. Really, the box is about 13 years old. It's not like this failure is shocking to have occurred at some point, given its age. So we're not looking at it like it's an indication of some bigger issue, but we will take it home and do failure analysis on it. But what we'll try to do is just to R&R the card, so we put the MDM will be back as a good spare, as Glenda said, and we'll bring that card home, and in due course we'll do failure analysis and see if it tells us anything.
Okay, I think we have one quick follow-up here in the room.
Aviation Week, and as for Brian Smith, you certainly mentioned the power and the thermal. What are other concerns if you lost another MDM? Other systems on the station that are high order.
So I'll give you two examples. We have two S-band strings, communication strings, and that carries the command, telemetry, and voice. Our ability to power up that backup string, which normally we keep off, requires an EXT MDM. So one of the preemptive measures we took right after we declared the backup EXT MDM failed, while we still have a good EXT MDM, we started powering on all those redundant systems. Rate gyro assembly is another one that's used in our guidance and navigation control system. We normally wouldn't power that on. It's there as a backup. So those are types of things that we have on right now. The helmet camera that we're going to use during this EVA, those radios outside are normally off. We require the EXT MDM to turn those on, so we turned those on right away. Once the MDM was declared failed, we knew we were destined for an EVA at some point, so we turned them on while we could.
Okay. One last one from Jim.
For Mike, this is Jim Oberg with NBC on the bigger issue, program issues. There was some talk that you would be looking at the previous replaced ORU, that the pump module, and possibly repairing it on orbit. Is there any status you can give us on that? And can you give us a status on any explanation from the Russian side on their hiccup on the 4-rev, on the 6-hour rendezvous that they had to abort? Have they given any reasons for that? Thank you.
Let's see, Jim. Let's see the 4-orbit. The 6-hour rendezvous abort. That was ultimately turned out to be an energy issue that ended up having the vehicle making a maneuver, taking too long to get itself into the maneuver for the burn, and it aborted the burn. They've taken some lessons learned from that, because ultimately the lower energy was due to within family performance of the vehicle, and so the Russians have gone off to make themselves more robust against the band of potential energy results from the orbit insertion and the on-orbit burns. So it really, overall, the vehicle performed within the nominal range, but the constraints were so tight for getting into attitude from a fitter standpoint that they didn't take into account that they could be in a position where they didn't quite get to attitude quick enough. And so they've opened up that window, and we believe future launches won't have this particular problem. Of course, folks all know that we do both the 6-orbit and the 34-orbit, the 6-hour 4-orbit and the 34-orbit rendezvous. We plan for both of those, and we plan for the 34 as a backup while we plan for the 4-orbit rendezvous. So this was well within our plan. And your first question was?
On the last contingency EVA, the crew replaced the pump module, and I understand it may simply be an electrical problem in the module that you may be able to repair on orbit and have the full unit back as a spare.
Yes, that is. We're assuming that to be the case. The team has some ideas about how you put this valve on a QD in between the line to the pump and the pump itself, and then we can jumper into the connector that goes to the module, so that valve can operate separate from the failed valve inside. But I haven't gotten a recent status, Jim. We have some time to work this given the number of spares we have on orbit. But the team is off looking at that. I just haven't had an out brief yet. We have not turned on Boeing to go build this mod kit yet. I know that for a fact. So, but I hadn't gotten a briefing recently on it.
All right. Well, that's going to wrap it up for us today. Thank you to all of our briefers. A couple quick programming notes for you coming up. As always, you can tune in to Space Station Live every day at 10 a.m. Central, 11 a.m. Eastern for all the latest on life on board the International Space Station. More immediate, we have our launch coverage of today's SpaceX mission going on the air at 1:15 p.m. On NASA TV. That launch scheduled to take place at 2:25 p.m. Central today. And assuming a launch today and a spacewalk on April 23rd, our NASA TV coverage will begin at 7:30 a.m. Central. As always, you can get all the latest updates on station news on our website at www.nasa.gov/station. Thanks for joining us today.